So today it's a pleasure to welcome our speaker, Dr. Bruno Guiderdoni, and apologies to him for some of you may have spotted the typo that came onto some of the flyers that were circulated early on. He studied physics and astrophysics at the University of Paris, where he received his PhD, and has subsequently been at the Centre of Research in Astrophysics in the University of Lyon, where he has been there the Director of Research. His main field of research is observational cosmology, and is specifically the formation and evolution of galaxies. But as well as his extensive writings on science, he's the director of the Islamic Institute for Advanced Studies and the Cultural Centre that is there in Lyon. And he's published around 60 papers on Islamic theology and mysticism, especially on issues of Islamic spirituality and epistemology and science and religion. So it's a pleasure to welcome Bruno to come and talk to us today on the subject of Kalam philosophy, Islam and science.
Thank you very much. Good morning. Assalamu alaikum wa rahmatullahi wa barakatuh. Thank you very much, Keith, for the nice introduction. I'm very pleased to be here in Cambridge, and specifically here at the Faraday Institute. And the organizers have asked me to talk about Kalam philosophy, Islam and science. And probably the idea behind this request has been the books which have been written at the end of the 19th century, at the beginning of the 20th century, by well-known scholars such as Ernest Renan in France, or Ignaz Goldziher in Austria and Germany. And these scholars have published books and papers, Islam and Science for Ernest Renan, Beatitude of the Old Islamic Orthodoxy toward the Ancient Sciences for Goldziher, and they share the idea that because of its theology, Islam was unable to have a proper relationship with reason in general, and to develop sciences except during a very brief period at the beginning of the Abbasid Caliphate, that is during the 9th century, and they disagree on the duration of this period. For Renan, it's something like 50 years, a blossoming of sciences for a very short period. For Goldziher, it's a little bit longer, but it's not more than 1 or 2 centuries. And we can think that these ideas were ideas of early scholars in Eastern studies, and that now we know that it is not the case. And as a matter of fact, these ideas, as you know, are very present among many people now, and I will just cite 2 examples. There has been this famous lecture given by Pope Benedict XVI in 2006 in Regensburg, in which he tried to think of a relationship between Christianity and philosophy and reason, and for him there is a deep relationship between the Christian faith and reason because of a logos, a word which has 2 meanings, a religious meaning and a philosophical meaning. And on the contrary, he said, I quote the Pope, for Muslim teaching, God is absolutely transcendent. His will is not bound up with any of our categories, even that of rationality. And as you know, this speech triggered a lot of anger in the Islamic world, but subsequently there was a call for more dialogue, and there was a well-known call called a common word, which was issued by Muslim scholars, and there was some dialogue after the speech. But what the Pope was thinking probably is that for Muslim teaching, God is only transcendent. When the Pope says God is absolutely transcendent in the Islamic faith, he probably means for the Islamic faith, God is only transcendent, because for the Christian faith and for the Jewish faith, God is absolutely transcendent, but he's not only absolutely transcendent. And to go to another field, there is, for instance, this a lecture which has been given by Steven Weinberg and Neil deGrasse Tyson. So they are scientists. Steven Weinberg is a Nobel Prize winner, a physicist. Neil deGrasse Tyson is an astrophysicist who is also very well known for his popular outreach. And they have given, probably in California, a talk which is called The Intellectual Collapse of Islam. It's on YouTube, but it has been posted on YouTube just 2 years ago. So these are things which are in the news. And for them, Islamic theology was unable to get the concepts of causality and natural laws, and this is the reason of the intellectual collapse of Islam, of the self-destruction of Islamic science. And for them, one scholar has to be blamed specifically. Al-Ghazali, whom you may know, he is one of the most famous theologians in the Islamic world, and his importance in Islamic thinking can be compared to the importance of Thomas Aquinas, for instance, in Christianity. He lived at almost 9 centuries ago, and here this is a very funny picture drawn from the YouTube, a snapshot of a YouTube video in which you see Neil deGrasse Tyson pointing finger accusing Al-Ghazali of being responsible for the intellectual collapse of Islam. So I'm starting from this point, and what I would like to say, I hope to convince you, is that one, Al-Ghazali was not responsible for the intellectual collapse of Islam. And second, that the intellectual collapse of Islam is a construction of the early scholars, those we have seen previously, Renan, Goldziher, but recent studies in the West have shown that the Islamic science has had an enduring development for many centuries and did not stop during the early Abbasid Caliphate or even later. So I will have 2 lines of arguments. One is the history of sciences, and the second one is a kind of review of theological arguments. I will start my talk by recalling a few basic principles of Islam and how Islamic thinking developed in the early period. Then I will go to Kalam philosophy in general and to Al-Ghazali more specifically. I will ask the question, fundamental question, did Al-Ghazali deny causality? And I will try, as a conclusion, to draw a few lessons for today. Let's have a brief look at transcendence and immanence. For Islam, God is simultaneously transcendent and immanent. He is transcendent, that means that he cannot be described or known by our categories, but simultaneously, God is present. He can be described by human categories, at least in a symbolical way. These are. So, and these are 2 positions which are in some way, which are not compatible. But that's Jewish and Christian theology, transcendence and immanence. God is transcendent, is different, and he is close to us. And we have that in Islam too, obviously. Otherwise, that will not be monotheism. And there is this well-known verse of the Quran which says, nothing is like him, like God, and he hears and sees. What does it mean? Nothing is like him, and he hears and sees, and we hear and we see. What does it mean? So all the theologians have tried to comment on these points. And obviously, God is intelligible, at least partly, through the immanence. And that means that God is present. He speaks to the human being. He acts in history. In Judaism and Christianity, that's the same. And for Muslims, the way he has acted in history is by the revelation of the Holy Quran, which is the initial miracle of Islam. It's a book. It's God's speech made in a book, incorporated in a book, I would say, in a human language, that is Arabic. And this book has been given to a prophet, Prophet Muhammad, who is not the author of the Quran. He is just the transmitter of the Quran. And there are many things in the Quran. It's a bit strange for people who have a Jewish or a Christian culture and who are trying to read the Quran, because in Jewish scriptures and Christian scriptures there is a history with a beginning and end. In the Quran, the things are a bit mixed up, and one needs a lot of reading in order to understand the hidden order which is present in the Quran. And there are many things in the Quran, but there are a lot of
verses which prompt the reader to ponder and meditate upon the natural phenomena as an evidence for God's power and will and wisdom. God is the creator, as in Judaism and Christianity. He has created the world out of nothing, and he renews the creation at every instant, which is an interesting point because it's going to be the matter of a discussion in this talk. God renews the creation at every instant. The creation is not let alone. It cannot exist, it cannot be maintained into the realm of being without God's permanent intervention. So very soon in the development of Islamic thinking, there has been this idea of two books, which you can find probably also in Judaism and Christianity. The Book of Existence and the Book of Revelation. And both books are created by God's speech. When God wants to create a thing, he says, be, and the thing is. When God wants to reveal the Holy Quran, he says to Prophet Muhammad, read, and Prophet Muhammad reads. So both books are created by the imperative mood, the fact that God asks things, and both books are characterized by signs. That's the translation of the Arabic word ayah, which is used for phenomena, and which is used also for verses. These are two books, these are two worlds, these are two worlds, and these books and these worlds have the same author, and consequently, they cannot be in contradiction. And the world is intelligible because God has created the human being. He has put some of his intelligence into the human being, and our intelligence finds God's intelligence in the cosmos, and this is the reason why there is at least a partial intelligibility of the world. There is also another source of Islamic thinking, which is the prophetic traditions, what's called the hadith, the prophetic traditions. And I'm going to just comment one very interesting prophetic tradition for the topic of today, that is the relationship between science and religion. It's a story that took place in Medina, the city where the Prophet Muhammad has been exiled. And he went through a place where there were palm trees, and the farmers asked whether it was necessary to graft the palm trees in order to get dates. And the Prophet said, no, it's not necessary. So the farmers did not graft the palm trees, and the crops were very bad because it's necessary to graft the palm trees in order to have dates. And so they complained to the Prophet, and he said something very important. You are more knowledgeable than I in the best interests of this world of yours. That means that there is a whole field in which religion has nothing to say, a field which is neutral with respect to religion. And techniques and science is in this field. Religion has nothing to say about the need to graft palm trees and to obtain dates. So that's very important, and of course this is where the scientific pursuit can be located. On this basis, after the rapid expansion of Islam, there has been the development of Islamic thinking during the first centuries of Islam, mostly the 8th and 9th century, that is the early Abbasid Caliphate. And this is the list of all the sciences and domains of knowledge and fields of knowledge that developed at that time: the sciences of the Quran, the sciences of the prophetic traditions, the schools of jurisprudence, that is the codification of the Islamic law from the sources of the Quran and the Hadith, to get the status of all the acts which can be performed in society. Are they mandatory? Are they forbidden? Or are they neutral? And there are also three big streams of thinking: Islamic mysticism, which is called Sufism, Islamic theology, which is called Kalam, a word that means speech, because it's what we can say about God and about revelation, and Islamic philosophy, falsafa. And at that time, too, in the early Abbasid Caliphate, there has been a very significant event, which is the epoch of the translations. I'm citing Dimitri Gutas, an American scholar, who has written this very interesting book, Greek Thought, Arabic Culture, about this period of the translation. He has studied specifically this period, and he says, the Greco-Arabic translation movement of Baghdad constitutes a truly epoch-making stage by any standard in the course of human history. It is equal in significance to and belongs to the same narrative as, I would claim, that of Pericles' Athens, the Italian Renaissance, of the scientific revolution of the 16th and 17th centuries. And Dimitri Gutas shows that almost all non-literary Greek texts were translated into Arabic during the early Abbasid Caliphate with the Caliph Al-Mansur, Al-Mahdi, and Al-Ma'mun. And he shows that it was not just a capricious idea of the caliphs, but all the classes of the Abbasid society were interested by science, the physicians, the soldiers, the traders, and so on and so forth. And there was an extraordinary appetite for knowledge, which probably was at the beginning mostly triggered by political, ideological or apologetic reasons. But very soon it triggered a genuine interest for science. And I'm going to focus now on astronomy, which is my field, but it's just an example of what happened also in other fields, such as medicine or physics or engineering. There has been a very interesting book written by Georges Saliba about the history of Arabic astronomy, and Saliba shows that, contrary to the popular idea, popularized by Ernest Renan, the translators were not only translators. They had to design a new vocabulary, and they corrected the Greek manuscripts, which were full of errors. For instance, here, Georges Saliba comments on the correction of Ptolemy's Almagest. The Almagest is the main astronomy book of a Greek period, Hellenistic period, and it was full of computational errors, which were corrected by the translators. For instance, here, the duration of the lunar month, here in the Greek and in Arabic. And so they translated and retranslated and retranslated the manuscripts, and the translations improved. And very soon, these corrections became new research, and with the idea that it was very important to get new data, that the Greeks had accumulated data for centuries, and now we Muslims have to accumulate new data. And so they develop new instruments such as the astrolabe, and they wrote catalogs such as this catalog, one of the first catalogs, the Book of Fixed Stars. And with this new data, which were used with the old data from the Greeks, they had a series of data on centuries, and they were able to improve the computation of the inclination of the Earth axis, the precession of the equinoxes, and so on and so forth. So that this is to illustrate this blossoming of science during the Abbasid Caliphate. But I will come back to science in a few moments. In that time, too, during the 9th century, so that was an extraordinary period in Baghdad. Baghdad was at that time the largest city of the world, with something like 2 million inhabitants. Many, many different cultures, many different religions were present at that place. And Kalam developed during this period, and the questions that were studied at that time were mostly the consequences of God's oneness, which is the fundamental tenet, the fundamental principle of Islam, what's called Tawheed in Arabic. God is one. What does it mean? What is the relationship of his essence with his attributes? That's a relationship of immanence and transcendence. And how can we understand the verses of the Quran in which God's face is mentioned? What does it mean? What does it mean, God's face? What does God's hand mean? If God is absolutely transcendent, what's the meaning of that? Another subject which has been studied at that time is the theory of human acts and God's justice. God is powerful, who is creating the human act? God or the human? If the human being is creating the human act, that means that God has a limited power. If God is creating the human act, what about God's justice? How can God punish somebody if he has created his act? So this is the kind of debate which took place during that time. And also there was some debate about the status of the Quran. Is it uncreated or created? If the Quran is uncreated, that means that God's speech is uncreated. It starts to look like Christianity, with God and God's speech. Both of them are divine. So does it mean that the Quran is created? But if the Quran is created, that means that it's more relative. It can be criticized. So these are the debates that developed at that time. And mostly there were three streams. But the traditionalists who refuse rational thinking, and the leader was at that time the famous Ibn Hanbal, and the Mutazilism, the Mutazilite, they emphasize the importance of reason. They are considered as the rationalists of Islam, and later on there was the Ash'arites, who look for a point of equilibrium between reason and faith. And this is the mainstream theology in Sunnism, in the mainstream Islam, I would say. At that time also, the mutakallimun, the theologians, the Islamic theologians, developed an interest for atomism. As you know, atomism developed in Greece 25 centuries ago within materialism. The materialists of the ancient Greece believed in an eternal, infinite universe with only chance and no causality. There is no reason for the appearance of Earth or the human being, only the fact that during eternity the atoms have been able to stick together, and eventually things happen, forms happen, planets, human beings happen because of the infinite time, and the fact that chance ends up with making all sorts of things. But there is no causal connection to the existence of things in the early materialism in Greece. And so Aristotle, as you know, opposed to atomism. For him, there is causality. For him, there are laws which produce things, and there is no chance, except at a very low level. But in the mechanism of the world, according to Aristotle, there is a strong causality. So why did most Islamic theologians adopt atomism? There's some debate about that, but since most Islamic philosophers were Platonicians or Aristotelian, maybe the theologians were interested in contradicting the Islamic philosophers, so they took the opposite viewpoint. There is this word, dharra, which means a very small particle in the Quran, so they may be interested by developing this idea. And they also, according to Wolfson in his book, The Philosophy of Kalam, they liked the absence of causality. And so they just needed to replace infinity plus chance by God's power. So they have absence of causality plus God's power, and that makes the atomism. And God does not cease to create the atoms, that is their substance and accidents at any time, and there is no causal power in atoms. So that gave birth to various levels of what's called occasionalism. You may have heard of this term. Occasionalism is a philosophical doctrine, which this word was, it appeared during the 17th century in writings of a well-known French philosopher called Nicolas Malebranche. And that's the idea that God does not cease to create anew the world at any time, and there is no causal power in the things. And moreover, according to Malebranche, the ideas of the things are even created in our mind directly by God. And as you know, Malebranche paved the way for Berkeley and idealism. So Islamic theologians were more or less occasionalists. And so the regularities of the world are not due to a connection, a causal connection, but to a habit established by God's will, which is called in Arabic ada. It's a habit. God behaves like that. And so we observe God's habit, but there is no causal connection in things. And God does not change the way he acts, and this is the reason why we see regularities in the cosmos. And these regularities can even be mathematical regularities. We know from the Bible that God has created the world ex numero and pondere in Latin. In Arabic we find that the sun and the moon are ordered according to an exact computation, a husband, an exact computation that moves the things. In the framework of Kalam, there has been this idea of a Kalam cosmological argument, which is based on Aristotle's immutable prime mover, but developed in the context of a falsafa by philosophers such as Al-Kindi and Averroes. The argument is very simple. Everything has a cause, and the cause has a cause. Since infinite regression is impossible, there must be a first cause. It is called the Kalam cosmological argument, but it developed in the field of Islamic philosophy. Because for theologians, God is the prime cause already. It's not the argument of a chain of secondary causes that leads to the prime cause. There are no secondary causes for most of Islamic theologians. So it's wrongly called Kalam philosophical argument, but it's true that many theologians were also philosophers. So sometimes it's difficult to see whether they are thinking as theologians or whether they are thinking as philosophers. So it's philosophically discussed and criticized by Al-Ghazali, because Al-Ghazali has a strange idea about infinity. All the argument is about infinite regression. You understand? What about this infinite regression, which is impossible? And Al-Ghazali is not very sure about infinity. Infinity is a problem during the Middle Age, even for Jews and for Christians. We can say that God is infinite, but what does it mean in the world, infinity? And as you know, this argument has been revived by William Craig in his famous book, the Kalam Cosmological Argument. So he's paying his credit to the Kalam. But this book discusses modern philosophy and modern science. It's not a history book. It's a book about contemporary arguments drawn from cosmology and philosophy. Let's go to Al-Ghazali now. Al-Ghazali was known in the West, in the Latin West, under the name of Al-Ghazal. He's an Ash'ari theologian, a mainstream theologian. He's also a Sufi, and he knows falsafa, he knows philosophy very well. And he knows philosophy so well that his books were translated into Latin, and the Latins of the Middle Ages believed he was a philosopher. And for him, reason is God-given, and there is only one truth. There is only one truth because there is only one God. Reason is given by God, and there cannot be any real contradiction between the results of reason and the textual indications drawn from the Quran and the prophetic tradition. So what do we do when there are apparent contradictions? When there are apparent contradictions, according to Al-Ghazali, it's the fault of the scientists and the philosophers who have made errors in their scientific work, not as believers, but as scientists or as philosophers. They have made factual errors or the errors in the reasoning, and they have been led to conclusions which are at odds with revealed truth, and this is a signal that they have made errors. And so Al-Ghazali writes a very well-known, which is called The Incoherence of the Philosophers, Tahafut al-Falasifa, and he acts as a philosopher. So he shows the errors, between quotes, by philosophical arguments, without invoking the Quran or the Sunnah. He just uses reasoning. Of course, that's medieval philosophy, so it's difficult to understand for us. But he was believing at that time that he was correcting the errors of the philosophers. 1 century later, there was this other famous scholar, Averroes, who was an Aristotelian philosopher and also a judge, a religious judge in Cordoba, in Spain, Muslim Spain. He was a Qadi judge. And for him, reason is God-given and there is only one truth. That's exactly the same sentence. There cannot be any contradiction between reason, which is God-given, and revelation, because our reason has been given by God. So if it is properly used, reason cannot bring any contradiction with revelation. So since there is no contradiction, we can practice philosophy, and the practice of philosophy is mandatory because he is a judge, so he puts a statement about philosophy. A society as a whole has to practice philosophy, and we would say science now. There is only one truth, and so how to deal with apparent contradictions? When there are contradictions, the theologians have to come back to the text and provide us with another interpretation. This is a very modern statement, which has been written by Averroes in the 12th century. The book in which he makes this statement has not been translated into Latin and was not known by the Latin. Its translation into European languages is rather recent. It's something like 1 century ago. And this is the reason why, during the Latin Middle Age, it was believed that Averroes was defending the double truth. There is one truth as a philosopher and one different truth as a believer. That's not true. That's not true. That's an improper understanding of a partial translation of Averroes' books. Otherwise, Ibn Rushd says, we would be led to claim that God says things that are obviously wrong. If science says that the world has been created as 13 billion years, we cannot make God says that the world had been created in 6 days with 6 days of 24 hours. That means that the days have to be interpreted. That's ta'wil, interpretation. That's fundamental. So there is, I don't want to be too long, so I will skip that. There has been a whole debate about the eternity of the world and temporal origination. God, with Ibn Sina, Avicenna, Al-Ghazali, and Ibn Rushd, Averroes. I will probably skip that. Just the idea is that for Ibn Sina and Ibn Rushd, the world is eternal. They find that in the Aristotle, but Aristotle demonstrates that the world is eternal. That's medieval demonstration, which is wrong. But he thinks he had demonstrated that the world was eternal. For Al-Ghazali, the world cannot be eternal because he finds in Revelation that the world has been created. And for him, creation means creation in time. So Al-Ghazali tries to demonstrate that the world has been created in time. So these are not religious arguments. They are philosophical arguments on one side and the other. The interesting idea proposed by Ibn Rushd is that creation means a metaphysical dependency and not creation in time. That means creation means that the world depends on God. It doesn't necessarily mean that the world has been created in time. And the argument there is about necessity. Is the world necessary? If it is necessary, it is eternity. It cannot be absent at any time. And so we also have this problem of necessity and possibility. Just a quick illustration. In contemporary cosmology, you have heard probably of the apparent fine-tuning of the properties of the universe, but this apparent fine-tuning are explained by the multiverse. And the multiverse requires an overarching law which produces the universes with derived law. And the debate is about the necessity of this overarching law, because if there are several possible overarching laws, why this one rather than the other one? So there are several possibilities. One is that everything which is possible actually exists in the universe, which is the old idea of materialists. This is this one. It may turn out that there is only one possible overarching law which will turn out to be necessary, but we are still looking for that. We don't know. So this is a possibility. Everything which is possible exists, or there are several possible things, and only one exists. So that means that we have to understand why this one rather than the other one, why this overarching law rather than the other one, why this variety of superstring theories rather than the other ones. And Al-Ghazali calls that the problem of preponderance. What gives preponderance over all the possible things to select one possible thing that appears in the realm of existence. And that's a problem of existence. What about the criticism of causality? Al-Ghazali did criticize causality, but necessary causality understood in the Aristotelian way. The assertion that the connection observed between causes and effects is of logical necessity. And he says, observation proves only a simultaneity, not a causation. This simultaneity is a constant conjunction due to God's habit. And what is interesting is that creates the knowledge of habits in our minds, not directly, as Malebranche will say much later on, but through the observation of natural phenomena. That means that we build up our view of the cosmos by looking at phenomena, and that's the result of this observation that makes practical causality be known by us. For Al-Ghazali, in order to be an agent, one needs free will, the power of acting, and the knowledge of the consequences. Things cannot be agents, and only God is the actual agent, because God is the only one who has the knowledge of the consequences. That said, it's very important to understand that God cannot create the impossible, Al-Ghazali says. He cannot create the impossible, and we can trust that there is an overall coherence in the world. That means that, yes, Al-Ghazali is an occasionalist, but he is a very moderate occasionalist, much more moderate than many of his fellow theologians, and more moderate than many philosophers during the modern period, including Nicolas Malebranche, for instance. And Nicolas Malebranche, you may know, but he was also a scientist. He was also a mathematician and a physicist, in spite of his very extreme ideas about occasionalism. The idea is that miracles are exceptionally possible, and this is the reason why Al-Ghazali defends his view of practical causality instead of necessary causality, because in necessary causality, God has no choice. He has necessary to create the effect after the cause. He has no choice, so there cannot be any miracle. And as a theologian, Al-Ghazali wants to defend the idea that miracles are possible, and this is the reason why he has this position of moderate occasionalism, in which he just let the possibility that miracles can happen. And there is also another aspect which I would like to mention, is that the fact that also Al-Ghazali was a Sufi, and he has had personal experiences, I would say, about God's action, which may have led him to think that, let's say, miracles are possible. So Al-Ghazali did not deny causality. He criticized necessary causality, and he defended practical causality. That means that we have to look at the cosmos in order to see how God behaves in the cosmos. And this is something which triggered the development of science, because I've left our scientists at the end of the 9th century, but look at, for instance, the Mahara School of Astronomy in Azerbaijan, contemporary Azerbaijan, with great mathematician Nasir ad-Din at-Tusi, who was the creator of spherical trigonometry, and who designed mathematical devices that were used later on, in Damascus, for instance, by this astronomer, Al-ad-Din ibn Shatir, that's the 14th century. That's not the Abbasid Caliphate. The Abbasid Caliphate, Baghdad has been destroyed by the Mongol. But he writes a book, a very famous book, in which he uses all the new mathematics in order to make a model that was better than Ptolemy's model in terms of mathematical predictions for the cosmos. And that's 2 centuries after Al-Ghazali. And the model was not just as good as the model of Ptolemy. So we know now that these models have influenced Copernicus. There has been this very interesting book by Georges Saliba, Islamic Science and the Making of European Renaissance. We know from Copernicus' work that he was informed about the development of Arabic astronomy. He used the Tusi couple, the Tusi mathematics, and we even think that he has had copies of Arabic manuscripts in the hands, because there are books, there are diagrams in his work. This is Copernicus, which parallel the diagrams in Tusi with the same letters in Arabic in Tusi and in Latin in Copernicus. That's Aleph, that's A, that's Ha, that's H. But he has reproduced the diagram by translating the Arabic letters into Latin letters. And the way there has been this influence is not well known. There are works now made by scholars in Islamic studies to understand how the manuscripts and the Arabic science was communicated to Copernicus. That's why I've talked about the destruction of Baghdad, but science continued also in Central Asia. There is a well-known Ulugh Beg Observatory. Ulugh Beg was the grandson of Tamerlan, the famous warrior and destructor of the East. But his grandson was a scientist. He created this observatory in Samarkand, and the Ulugh Beg Observatory, and they have produced tables with the best star catalogue of that time, the best determination of the sidereal year, the best determination of year of inclination. And there is a famous astronomer who worked at that time, Ali Qujji. We are at the 15th century. We know that several tens of astronomers were working at that time. And Ali Qujji, we are fortunate because we have a portrait of Ali Qujji. Most of these figures, we don't know how they were because there were no portrait, and that's one of the causes, to my eyes, of the poor knowledge that we have about the Muslim theologians and philosophers and scientists in general. But here we have, I'm going to stop. We have this Ali Qujji is asking for a grant, probably to the Sultan here, and he defended the independence of astronomy from philosophy. He argued about the rotation of the Earth by rejecting the traditional Aristotelian arguments for a stationary Earth. Exactly in the same way as Copernicus did 1 century later. There has been some recent studies about that, written by Jamil Recep, who is a Turkish scholar working in the United States. And even in the Ottoman Empire, there has been this big Constantinople observatory, 16th century, many different astronomical, this is a picture of the observatory, many different astronomical instruments and mechanical clocks. He worked on optics, astronomical tables, and even steam engines. So did Al-Ghazali deny causality? Yes, he denied necessary causality, but not practical causality. He was a moderate occasionalist. And so he can be considered in the broad field of all these people who criticized causality, including Hume here in Scotland. And as you know, causality has been also criticized by modern physics, and especially deterministic causality has been criticized. So did Al-Ghazali hamper or block the development of sciences in the Muslim world? No, factually no. Science developed at least until the 16th century in the Islamic world, that is for 8th century, there was an enduring effort of development in science in different places. That's true, depending on the circumstances and the political situation. And it may have, Al-Ghazali's criticism may have even produced arguments for favoring the development of observation experimentation because of the freedom from the submission to Aristotle and the excess of deductive thinking. Because during the Middle Ages, people were convinced that it was possible to deduce the whole of reality from first principles. You know, it's absolutely incredible for a physicist to think that for almost 2,000 years, people have believed that the trajectory of a stone was like that. It's incredible. And it's just because of guns that people became aware that this trajectory, which is the trajectory of a mobile according to Aristotle, it was wrong. So it's incredible. You have to look at phenomena. So they looked at phenomena, and they developed the observational science that I've described. So let me finish by asking what Joseph Needham's called the ground question. So if there has been this enduring effort in the Islamic world, how is it that modern science did not develop in the Islamic world? Nobody knows, because nobody knows why science developed in the West. This is the ground question. At least in two places there has been the conditions of the pre-scientific revolution during in China 2,000 years ago, and in the Islamic world 5 centuries ago. And we don't know. So this is a book which has not been translated into English. It's written by a Swiss physicist whose name is David Cosandé, Le Secret de l'Occident, towards a general theory of scientific progress. And David Cosandé reviews all the explanations which have been provided by literature about the origin of the scientific revolution in the West. He finds that none of the explanation is satisfying, and he proposes something which is his idea about the specific geography of Europe, which makes the existence of a system of several stable, wealthy states possible. So this is his ideas. But the interesting point is that we don't know, and there are several answers to this question. One of the answers is that it's a rewriting of the history of science, in which the modern science starts when ancient science becomes to be criticized. And that took place in the Islamic world 1,000 years ago, when a well-known physicist called Al-Ghazali, who was the favorite reading of Isaac Newton, Al-Ghazali, and who worked on optics, he started to contradict the Greeks on topics such as optics and astronomy. And there are people who are considering Al-Ghazali as the first modern physicist. So it may be a wrong effect of a division to see the Islamic world on one side and the European world on the other. Now I think that most of the scholars are thinking in terms of continuity. In terms of continuity, and there has been all these developments in the Islamic world for centuries, until the 16th century, and then, of course, obviously, there has been Copernicus, and there has been Galileo, and there has been Isaac Newton in the West. And where is the problem? So we don't know. It is, and there is a piece of history which is missing. It's the way the Copernican heliocentrism and the theory of motion promoted by Galileo and then by Newton, how these theories were received in the Islamic world. We know that there has been the translations of works on heliocentrism in the 17th century into Arabic. But what happened later? And what happened later took place in 3 empires which were not ruled by Arabs, they were ruled by Persianized Turks, and they were the Ottoman, Safavid, and Mughal empires, wealthy empires with a centralized bureaucracy, strong armies, a lot of guns, why didn't they develop an interest for science? And maybe they developed this interest, but it is still not known because many manuscripts are still in the libraries waiting for translations and studies. So that's a problem here. And so the problem also happens because of the development of a specific stream of Islamic thinking, which is Salafism. And Salafism criticizes altogether all the other streams of thought, the schools of jurisprudence, the theology, philosophy, and Sufism. And just to end up with just two illustrative examples, in 2015 there has been on the internet a lot of buzz about this Saudi cleric who demonstrated that the sun, that the Earth is stationary. There's no motion of the Earth. He uses Aristotle's argument. He was not aware that Ali Khujji, 5 centuries ago, criticized these arguments. He was not aware of modern science. He explained that the Earth is stable. So he made a fool of himself on the internet. He was very popular. But the point is that if you look at the date here, it's February 2015, and just a few months before, this young lady, Miriam Mirzakhani, who was born and raised in Tehran, was a mathematician and a professor at Stanford University. She received the Fields Medal, the highest distinction for a mathematician. Nobody has heard of that on the internet. And that's it. So that's the situation now. One sees people like this cleric, and one sees people like this extraordinary lady who unfortunately died in 2017. I will stop here. Thank you very much indeed.
Thank you, Bruno. It's fascinating. We've got a few minutes for some questions before we break, and then some longer discussion. I'd like to kick off.
Welcome.
Wait for the microphone. We'll bring the microphone to you.
Thank you. Please, sir, I can't quite understand whether Sufism helps or hinders in this kind of intellectual study of creation and the world in science.
Thank you very much for the question. Many of these philosophers and theologians were also Sufis. We were practicing Sufism, and that was a personal commitment. I think that the Sufis will have two ideas. First, they will like to contemplate the world, to see God's action in the world. The world is a collection of signs that show God's power and intelligence and wisdom. And so they will have this contemplation of the cosmos, this marvelment about the cosmos, on the one hand. On the other hand, Sufism is about something I would call a personal miracle. The fact that every one of us can have a personal relationship with God, which is obviously something beyond the grasp of science, which is something which is beyond natural laws. So we will have always this opening. And I think that Al-Ghazali's position tries to maintain the two points. The fact that the world shows order, the world shows causal connections, practical causal connections. There is coherence in the world, and there is also the possibility of the inner miracle, of a direct relation with God.
Thanks very much. I thought that was excellent. I have a question, actually a request for clarification. I think when you first mentioned Averroes, and I'm finding it difficult to pronounce either the Latin name or Ibn Rushd. So first of all, could you help me with the Arabic pronunciation of Averroes? And second of all, the real question is, I think when you introduced him, you said that in contrast to Al-Ghazali, when he viewed a contradiction between scripture and science, if I may phrase that in a Western way, he said the interpretation of Scripture has to be wrong. Whereas I think you said that Al-Ghazali did the opposite. So is that correct? And could you comment further on that?
That's a good summary of the situation. So yes, we know these great philosophers by their Latin name or their Arabic name. Avicenna, in Arabic Ibn Sina, Al-Ghazali, in Arabic Al-Ghazali, and Averroes, in Arabic Ibn Rushd. So they are in some way the same persons and not the same persons, because as you know, after the siege of Toledo in 1085, there has been these translations, but partial translations. Some of the manuscripts were found, not all the manuscripts were found. So all the Latin scholars had a partial view on these philosophers. So Averroes is not really Ibn Rushd. Al-Ghazali is not really Al-Ghazali, and so on and so forth. But you are exactly right in summarizing the two positions. They agree on a lot of things. They agree on the unity of human thinking. They agree on the unity of God, and they agree that there cannot be any contradiction between reason and revelation. But they disagree on a fundamental point, that is, who is going to come back home to do the homework? For Al-Ghazali, the philosophers have made wrong computations, I would say. There has been some mismatch in their pursuit of reason. They have to come back and redo the computation. Whereas for Ibn Rushd, that's the responsibility of the theologians. You guys, you have to come back home and see how you can read the text in order to avoid making God say things which are absolutely wrong. So this is and I do think that we have to maintain the two positions simultaneously. It is true that once science has shown things, we know that science is a complicated process, but when science has said things, we have to interpret the world in order to be coherent with the description of science. We have to interpret our text in order to be coherent with science. But on the other side, it is true that sometimes, as Al-Ghazali said, we scientists, we go beyond the domain of validity of our reasoning. And we say things about reality which are a bit too bold, and maybe they are wrong. So this is a kind of warning that Al-Ghazali is issuing for scientists, for philosophers. Maybe sometimes you go beyond what you can reasonably say on the basis of reason.
Thank you very much. At that point, I think we need to stop and take a break. That's been fascinating. Informed me, excited me. Thank you very much. Can you join me in thanking you?
Thank you very much.